Hello, people. I see most of. Oh, man, this class is getting a little bit smaller by the week, but I think this is about 70%. But anyway, so how is it going, guys?
Okay, sir.
Right. All right, Austin, thank you for answering on behalf of the class. You get a bonus 2% towards your grade. I'm just kidding. I'm just kidding. I can't give it away so easily. All right. You tech wouldn't allow me to. Um, Jadmar, how you doing?
I'm alright, sir.
Does the picture on my screen look like the picture on your screen?
It does.
Lovely. That means you have your floors in and you have a hole in your floor.
Yes, sir.
All right, sounds good. I wonder if I can assume that you're answering on behalf of the entire class. So everybody is here. Um, let me see here. Let me bring up our schedule and see where we're at. Okay, this is building information modeling. There we go. All right, so we are, today is the what? Today is the 19th. Come on. Come on, internet. Okay, here we go. All right. Today is the 19th. Man, how is it the 19th already? Man. No, the 9th. I was just wondering. It can't be the 19th already. And none of them wouldn't even correct me, eh? Hmm? If it was the 19th, that would mean that y'all models would be done already. Okay, cool. So we're gonna continue with the lecture presentations today in the lecture session. Which group is ready? I think we just have like 2 left, right? Which topic do you have?
Links model.
Links and models, and there was one that didn't get to present last week. Cause we're out of time. So links and models is today. We did yeah, model line, detail line. It's called
Yes.
good to go.
Yes, sir.
And then we have reference planes. We'll see if we can get to them. So we'll take those 2 for today, definitely. All right. On the practical side, today we're dealing with the terrain and the curved steps, right? Remember, I told everybody to do jumping jacks for this class, right? Because these steps not playing at all. But once you're able to build a custom step, I mean, I've seen in the past where students do this awesome sketch, you know, that they're going to have for the studio project, and only to come up on stairs and being totally flustered by how in the world do I create this weird stairs that has an angle and jut out and all kind of stuff. And so your design end up just getting normalized. Because you can only use the standard stairs. So that's one of the reasons why I this process that we're in, this building that we're designing together has a lot of non-standard elements, right? Go over to here. So if we take a look on our schematic design drawings, you can see that I should ask, you guys are seeing my screen okay? Not blurry for anybody? Somebody give me a confirmation on that.
Yes, sir.
Yeah, so clear.
Cool, cool. So we see a set of steps going up here. We see a little teeny one here, right? And then if we spin around, all right, I had these things, let me delete them. If we spin around here, this is kind of the star of the show. These steps that you see right here, that kind of goes up and around, and then it just emerges through this hole underneath the patio area, which is pretty cool, a nice architectural feature, right? We created these stairs last week, right? Which was kind of a, you know, for those of you who might be not used to stairs, it was a little bit of a, I guess, a challenge. But this is the one we're going to create today. And in order to create this, we need to create our terrain, right? So we're going to be looking on doing that using our contour line. So we're going to be using this drawing today, right? Remember, guys, if you can access the drawings on the mirror board, or you can access these drawings independently. If you go to the class website, you scroll down to the individual major project, and there is a link, access drawings on mirror board. Oh, I didn't give you another link. Oh, I think I had put it in the meeting chat. Oh no, it's below here, supporting files. So if you look right below the handout that we're using, on the supporting files, there's drawings for students. If you go inside that, you will see these are all the individual drawings. So you can actually download them to get the full view where you can zoom in, zoom out. All right. Okay. So, as per usual, I want you to get your rivets ready, and we are going to go through creating the stairs. The idea is that you should be about where I am on screen, right? Now, even if you're not here, at minimum, if you have the slab, you should be able to continue, right? And as usual, I will put the recordings up so that you guys can follow along. All right, you make it through today, you'll be at least about 70% complete, right? So I want you guys to keep up pace as we go through. All right. All right, guys. Let's get to it.
So now that we have our horizontal planes in, our main structure is done, and most of our walls and our internal stair, now what we're going to do is start with the terrain. We're also going to get in our external stairs, and from our understanding of what needs to happen, we have a stairs that will go around and go underneath the building, kind of like that, and comes up like that. Then we have two stairs that's going to go down here, and then we're going to have the terrain around this area. Now the trick with this section of the design is that the terrain needs to conform around the stairs that's here. So we're going to learn how to customize, how to mold the terrain in Revit. So let's get on the way. Okay, so what we need to do is take a look on what we have for our terrain. So if we look at our drawing here, amongst our drawings, we should see a terrain drawing. Now this drawing is available as a JPEG, so you can actually drag this into your Revit project. And the idea is we're going to use the outline of our site boundary to align and scale this terrain plan that's right here. Now in order to get the terrain plan in, we're going to look for the file called topo that's here, and we're going to drag that into Revit. First we need to, let's go to our site plan level, and I'm still going to be using the black and white version of Revit, and what I'm going to do is drag this in, and you should see this X here, and that represents where the terrain is going to go. All right, great stuff. Now what we need to do is we need to overlay and align our boundary. Now our boundary, let me see here, is, if we can find that. Oh, hold on, I think it's hidden. There it is. Okay, so here's our boundary line here. If I turn this off, right, so we can see our boundary there. I'm going to change my background to white using the shortcut CA. There you go. All right, so all we need to do now is to match this boundary that you see here and scale it. We need to scale this imported boundary to match this boundary. So to do that, we're going to select this here. We're going to use move, MV to move. Try and get this as close as possible. And we're going to drop that right here. Then we're going to use the scale tool, and we're going to click that point and get to that point, and then stretch it to that point. All right, and you can see that it's, you know, it's okay. Now it doesn't matter if it's not 100%. The idea is that we just need it to be accurate enough to trace the terrain. The next thing to remember is that terrains are an organic shape. So the shape of the terrain lines matter less compared to the height of them. So even if the terrain lines aren't the exact 100% shape to what these are, it doesn't matter. They need to be roughly the same, but they especially needs to be the same height. And if you can look on our drawing here, I'm just going to put a copy over here. You can see that these terrains here have heights. Now whenever you import an image into Revit, it's only going to remain on the view that you dragged it into, that you imported it into. Additionally, when you drag an image into Revit, if I head over to manage and then go to manage links, here we go here, you can see that under images, we now have an automatic link that's created. And what this is saying is that this image is linked into this drawing. So if we update this image, we can actually go here and choose reload, and then it will just update the link. Now, important thing to note about Revit is that even if you delete the original image file, Revit will still keep the image inside of the program. So even though it's linked, the image is also embedded in Revit. So if I go to this location here and I delete this pavilion topo.jpg, which is here, if I delete this, press delete, then this will remain and it will tell me that the link is broken, but the image will remain in my viewport. And that's a good thing. In case you give the file to somebody and they don't have this image, it will remain in the project. However, the disadvantage of that is that your project size now gets bigger because the image is actually embedded on your viewport. So all of those pixels are embedded in the project, right? But anyway, so we do have the heights here. So this is what we're going to use in order to begin tracing our terrain lines. Now, to start tracing our terrain lines, we need to head over to Massing and Site, and then we're going to see the Topo Solid tool. Now, if we hit the little down arrow that's here, you will notice that we see that we can create a terrain from scratch, a topo surface from scratch, or we can create it from the import of a 3D terrain drawing. Now, in this case, we have a terrain drawing, but it's not 3D. It's just a 2D flat plane. So we definitely have to create it from scratch, right? So we're going to choose that option. Now, here's the important thing about the terrain tool. Let's head over to the modify. Now, the first thing we need to do is to choose the boundary of our terrain. Now, what that means is what are the extents of that terrain? So what I'm going to do is I'm going to grab my circle tool here, and I'm going to just estimate the center of this, and I'm going to draw out a circle like that. So this is going to be the extent of the land, the base, the 3D base mesh that I have here. So usually you would make that a little bigger. We could make it into a square or a circle. It's up to you. Sometimes I tend to use circles, especially later if I want to carry it into a 3D program. I don't want my horizon line to end at a peak, but it doesn't matter. You can change this at any time. So this is establishing the boundary of our 3D terrain base. And once that's done, we're going to choose OK. Now it's going to ask us if we would like to the floors and whatever to go up to the bottom. We're going to say no, don't attach. So that is our base terrain. And if I look in 3D, you will see that's what it is. Now we created this on level 0, so you can actually see the foundations there below. Now if I click on this terrain here, I'm going to go back into Site. You'll see it highlighted there. But also under Modify Topo Solid, this is where we begin with the action. So we're going to choose Modify Topo Solid, and then we're going to choose Add Point. And we're going to add points to make up each one of these lines, and we're going to add them at the different levels that we see here. So the first one here is going to be at level 0. So we're going to make sure we're going to go to Modify Terrain. We're going to go to Add Point. We're going to make sure that that elevation point is at 0, right? And we're going to make sure that the base is going to be at the current level, which is the lower floor, which is currently the same as the project base point. So whichever one would work in this case. All right, so we are going to go ahead and put those points in. Now, before we can put the points in, you might notice now that we're not seeing the terrain, and that's because the surface of the land is covering up the terrain. So a quick way we can get around this is to just choose wireframe. So now we're seeing just the lines. All right, so at level 0, we're going to add our first point, and I'm just going to start from here. And what I'm doing here, I'm just putting points that are averagely along this line. Now notice that it doesn't have to be exact, but what I'm trying to do is to have them evenly spaced. Like, I'm not trying to put some closer together and some far away. I'm just estimating. So will be the way to quickly get through this process, because it might seem a bit tedious, but the idea is you don't need to be super precise, because the earth is a organic shape. So even if it's a little different, it doesn't really matter. What is important, as I said earlier, is the height. So now we're going to change the height. And if we look, our next terrain line here is going to be 500 millimeters. Oh, we can see it here, 500 millimeters. So we're going to change this to 500. And then we're just going to start to trace these out as well. Now, ideally what you want to do is when you're tracing this line, you're going to start to see the mesh start to generate. And what you want to do is try and align it to where you have the point. So for example, if I have a point here, I want to put another point here. If I have one here, I want to put one here. If I have one here, I want to put it here. So that's the general idea. And I want to try and stick to following that this line here as closely as possible. There we go. Oops, I have one there. Even if you skip out a point. So for example, if I went all the way and did this and I said, oh wait, I need a point here, you can just click it, go back and click it. It doesn't matter as long as you have this at the right height. Okay, so I finished the 500. So next is 1,000. So I'm going to start with 1,000 again.
Now, who remembers this from last semester? We did create a terrain last semester. Right? Chambers, how you doing? You hear Chambers? Hearing from Chambers. Alright, I'm finding the mute button. Alright, in the meantime, I'll wait on Chambers. Elandra!
Yes, sir.
Yeah, man. So, do you remember creating a terrain? You did it just yesterday, literally, right?
Yes, sir.
For the 3D modeling project, right?
Yes, sir.
All right, cool. You know, forget. That's good. That's good. The difference this time around is we're going to learn how to control that terrain. So it's easy. So for example, when you get a terrain, a contour diagram from maybe a civil engineer, and it has these terrain lines, that's all well and done. But suppose you have a roadway, a stairs, you want the terrain to dip in a particular area and rise in a particular area. That is the new addition, what we're doing this time around, right? So, a lot of sites that we have, especially in Jamaica, is sloped, right? And sometimes our design needs to follow the slope. And in this case, the design is following the slope. And the challenge that we have is that we have two stairs that is basically riding on the surface of the terrain. So we need to learn how to modify these points to do that. So that is the new thing that we're going to be tackling. All right, let's continue.
Terrain. And you may be wondering, why would we need to carve out the terrain? And the answer to that is what we're going to be doing. So for example, we have about 3 stairs that's going through the terrain. This terrain is representing it directly as how the surveyors have it. Okay, 3,000 now. So the surveyor, according to the surveyors that provided this topography, we are just representing the original topography of the land. However, when you start to install things in the earth, like stairs and walkways and stuff like that, it will edit or warp the topography, the original topography, depending on the shape of the element you're putting in the ground. So what that means for us is that the more points we put is the more points we have to move around once we start to carve out the shape. Okay, now we're at 3,500. So that's going to be this top one here. And I'm just trying to do this extra. Give You might see me moving a little fast, but that's okay. I just need to get roughly the shape. And the last one is going to be 4,000. And 4,000 is just going to be this guy. Oh, there's an overlap. Oh, my bad. 4,000. Yeah. Now, what's happening with some of these is that it's detecting that some of the points are overlapping. So you might get this sometimes, and that's okay. That's okay if we can't get any more points. Sometimes you have to move these points around in order to get what you want. Okay, let's see, add point. There we go. Right. All right. Good. So let's turn off wireframe now. Take a look at our mesh. All right, let's look at that in 3D. All right, so let's do shaded view. So you can see what we have here. So you can kind of see the terrain following our step up. And we can see this floating above the terrain here. Hold on, we do have an error with this point right here. So let's go back to site and take a look at what we have here. So let's go to modify sub-elements. So, oops, modify sub-elements. Some of these points that we see here are not correct. So let's see. We have 0, 5, 10, 15, 20, 2,500. 15, 1,005, 3,000. So one of these points, if you look at the 3D, right, this point here is 0, and that should actually be after 3,500. This should actually be 4,000. Let's isolate this so that we can have a closer look. So let's press escape, select the terrain, select this eyeglass here, and then we're going to say isolate element. There we go. Right, so we can kind of see the issue. Let's go to modify points. These points here are set to 0 by accident. So we're going to hold Control, oops, and click them. And we're going to set them to, it was 4,500. Yeah, 4,500. Because that should be the height of the tallest area. So that looks pretty okay now. All right, cool. Let's spot here, 4,500. Yeah, that's fine. All right, cool. Let's go and reset temporary height. So our building is back. And there we go now. Now you can see the terrain, the rough shape of the terrain. And it's looking kind of like what it should look like, right? Because this is sitting on a hill here. And then the stairs is going to be coming down this terrain and around. So the trick is that we need to get the terrain to match the stairs as it comes down here. And then we have 2 flights of stairs that's going to be coming down here. So we need the terrain to meet that level and follow it down. Right. Let me go back to site. Oh, the highest one we have is actually 4,000, not 4,500. So that's why it is a bit tall. So let's press escape and let's isolate this again. Isolate, and we're going to modify elements. Right, so we're going to make these points be 4,000. Yeah, so that's not so crazy as before. That's looking a little bit more natural. Let's go back now. All right, there we go. Okay. Now, before we get going, we do need to close up this end right here. So let's go to our upper floor, and we're going to just get a wall. So I'm going to go to architecture and grab a wall. We're going to use a, let me switch to dark mode so I can see stuff better. All right, so we're going to grab a generic 150 wall, and right now it's set to center, so I'm going to draw it there. I'm going to offset it, so let me align it, AL for align it there. Then I'm going to set my height. So if I look in 3D, of course this wall is tall, but I need it to go from this level to that level. So if you remember how the levels are, we can say our base constraint needs to be on the, I believe it's the cantilever level, and then the top constraint needs to be on the upper floor. There we go. So using levels, we can get stuff to line up exactly like what we want. All right, good stuff. All right, so let's get in our stairs. So what we're going to do, we're going to work on the harder stairs first, which is going to be the curved stairs. The curved stairs is going to fall inside of this area here. It's going to wrap around parallel to the wall, and then it's going to come underneath this area like there. So to do that, we need to go to a top view. And what I'm going to do in this top view, I'm going to go to my my view template, and I'm going to set my annotation sections to be halftone. Okay, right. So that way my section lines don't get in my way. That's here. All right. So now I'm looking at the terrain in the background, which is fine. But my stairs needs to come around. So let me take a look on my floor plan. So you can see that my stairs is moving perpendicular, and then as it turns the corner, it takes on its own curve that's here. So we're going to have to estimate part of this, but a large part of it is going perpendicular to this curve that's here. All right. So all right. We can also see the number of steps that is here. If we look in our sketch, you can see that there are 31 steps. So that helps us to get an idea of the count, and then we have a landing that's here. So this is actually much more visible from the lower floor. So we're going to use the lower floor here because we can see this curve much better. All right. Let's set the view template of the lower floor to use our architectural plan, which will set all our lines to be the proper color. All right. Now, obviously, this is going to be a custom stair. So in order to get a custom stair, we are going to need to use some specific stair features. Now, before we jump into our stair tool, whenever we're doing this type of stairs, which is going to be a highly customized stairs, it's a good idea to sketch out our stairs first using line work. And then we use the stair sketch tool and just trace those lines. So let's figure out how would we draw these stairs here. Now, right away, we can see that we have the number of steps. And if we look at the detail area here, we see we have the width of the stairs. And we have we can tell that this is going parallel to this edge here. And then as soon as it turns a corner, it's coming out underneath the patio that we have here. So if on our lower floor, we can basically use this as a guide, and then we know that it comes out somewhere right at about grid line A3, which is this grid line here. So if you look where grid line I and A3 meet, that's going to be right here. So if we look closely, we can see that this point here is this point here, and the stairs comes just a little bit shy of that. So it's probably going to end somewhere around here. It's going to be our stairs. It's going to come around like about that, and then offset on the other side like about that. So it's going to be something like that we have there. So let's go ahead and we're going to go to annotate, and we're going to use a detail line to sketch out our stairs first before we start to model it. So right away we can go to pick a line, and then we're going to use the offset that's here, and we know that the width of our stairs is 1600. So once we do that, we can offset this at 1600. That's here like that. That's good. And what we can do, we can click on this and we can give it like a different line color. We can make it hidden. That way it's dashed. We can use that hidden, so that way it's green, so we can identify it a little better. All right, so let's go ahead and go to pick lines again. So we're going to go to annotate, detail line, and pick lines, and we're going to offset it again 1600. This time we're going to do it the other way. All right, so that line is also going here. And then here comes the tricky part. Now, in order to guess where this will end up, we know that it will end up somewhere about here. What we can do is let's go to detail line, and we can use this tool here, right? And what this curve tool will do, the end arc tool, is that it will allow you to come off of the previous curve with a smooth curve. So we can start here, and you can notice how it will kind of curve this the best it can based on the last curve. Now if we go to the upper floor, we know that we will end up being somewhere about right here. Let's go back to the lower floor. So we're going to end up somewhere around between A3 and I, somewhere about maybe about here. Press escape. There we go. Oh wait, let's also change this to hidden. No, not hidden. It's hidden lines. Let's go back to detail line. Let's make sure that we are on hidden lines. All right, so let's offset this 1600 like that. All right, good stuff. Then we are going to close this up. So now there's a particular trick to put in that end line here. To be as accurate as possible, we can't just draw a line from here to here. This is offsetting, right? So for example, if we go here and we draw a line from here to here, technically this may not end up being correct. So don't do that. Because this is a curve, it has a center point, which is somewhere here. And the idea is to draw that end line, you need to draw it from the center point to where it hits the furthest line in order for you to get an accurate end line. That's going to end up being our tread line. Because it's on a curve, you have to go according to that that diameter. So we need to get the center point of this that's right here. And in order to do that, we can just turn this into a dimension here. So this will end pretty much at the center point there. So we have that point. Now, what I usually do is I try and mark it. So I will just use my annotate tool, and I will just use a circle and drop a circle right there. Oops, drop a circle right here. Right, so that marks that point. That's to this point. Then also I want to do the same thing for this point, which endpoint is right here, which luckily we had already marked. So because that's what we use to construct this curve. So I'm going to put so in case you don't have, so imagine that you had already deleted these lines. You wouldn't have had those lines there. So I'm going to put a circle there. Now, the reason I put a circle there, because it's just easy to snap to. It makes it easy to snap to. And I'm just using a detail line because I intend to delete it when I'm done. I'm just putting it there. So there we go. So now what we can do is when we go to detail line, the line here, I can draw a line from here all the way to the final point here. And same thing again from here to the final point here. Then what I would do is trim this TR like that and trim this like that. So by right, this is how this should end, like that. Because these threads are on a curve, so it has to be based on a common center point. All right. If it's not, then it's not going to give you an accurate calculation when you're doing the threads. So the same thing for here as well. I am going to now grab my tool, my line tool. I'm going to draw a line to the furthest point here, and I'll draw another one to the furthest point, which is here. And then I will use trim to trim up these like this. Because remember, essentially what you're doing is you're creating a set of stairs from here to here. Then this is going to be a landing, then a set of stairs from here to here. So all of the risers in here has to be based on this radius that's here. All right, so I can delete these lines so that this isn't so confusing. There we go. Also, I mean, our terrain lines are a little bit getting confused with our other lines. So what we can do is we can go to our architectural site plan view template, and we can go to model, and we can say topo solid. Let topo solid lines be, we could make them dashed and green. Yeah, let's do that. That's these lines here. Hold on, let's see. Let's go back. Topo solid. Surface lines. So changing the surface lines will only change this outer line here, but to change these lines, we have to change the contour. So let's go back into visibility, and we're going to go back to topo solid, expand it down, and now we have to change, we have to also override the primary and secondary contours. So we'll just do that for now. So we'll just choose 2.5, make that green. Okay, and 2.5, make that green. Okay, 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 and okay. All right, so now the contour lines are dashed. Well, the cut line isn't dashed, so let's also go ahead and change that. So we go back here and go back to topo solid, and let's change the cut lines here. Cut lines for topo solid. Yep, we're gonna change that to 2.5 and let that be green. There we go. So now all our contours are dashed. So we shouldn't be confusing it with our walls for now. All right, so now that we have this, what we need to do is we need to generate some risers that's going to be here. And if we look at what we have here, let's look at our lower floor, because that gives us a better idea of these steps. We can see that we have about 15 risers that's going to be on this segment that's here. And then we have 16 that's here. So all of these risers needs to be generated evenly spaced. So how you use the array tool is first you need to select what you want to array. And remember, when we say array, we are simply saying that we want to create some lines that represents our risers, and each of these lines comes from a center radius like that. So we are arraying a bunch of lines between this point that's here and this point that's here. So that is essentially what an array is. In this case, that is going to be a circular array. Okay, so select our first object here. We're going to choose the array tool, which is here. We're going to ensure that we put it on radial array, right? Then we want to ensure that we are arraying to the last point. So we're going to so what this is saying is that it's going to array something at a radial. It's going to array 3 of them between the first and the last point. Now we already know that we want to have 13, or rather we want to have 14, not including the first one, 14 arrays that goes between this point and that point. And the last one is going to cover this last point here. So I'm going to say 14 here. Then we need to place the center of the array. So we're going to choose place, and we're going to place the center right here. Remember those circles that we put earlier? So it's becoming very useful. All right. So now we're going to choose the first point of the array, which is here. Then we're going to choose the last point of the array, which is here. And there you have it. It created 14 arrays right here, which is great. So then we have our first set of stairs, which is here. All right. So next, what we want to do is do the same thing for here. So the same thing again, we're going to choose the last point here. We'll go to our array tool that's here. And same thing again, we're going to put it on radial. In this case, we need to create 15. There are 16 steps, so not including the first one, we need to create 15. So we're gonna say 15. That's here, and we're gonna align it to the last one, and we need to place this here at the center. No, this center here. All right. So we're gonna start here, and then we're gonna end here, and there we have it. All right, and of course we can actually change the amount of arrays if we wanted to. So just in case you might have put the wrong number, you can always click the number and change it from 16 to 18. Doesn't matter, it's all adjustable real time. All right, so we have now drawn our stairs in a sketch format. Now we need to actually put stairs in. So what we're going to do is we're going to head over to our stair tool. So we're going to go to architecture, then
My computer freeze. Are you guys hearing me? Mic check. Yeah. Okay. I think the screen share froze or something froze. Yes, something froze. Hold on a second. Yes, program crashed. Yep. See if we can get it back. All right, let's continue.
Stair tool. So we're going to go to architecture. Then we're going to head over to stair. Now, this time around, we are going to be using the sketch tool here, create a sketch. And this is how we create custom stairs, right? Whereas before we were creating just a run and a landing, a straight stair.
Yeah, I think okay, hold on a second. What is happening? Oh, ta-da, ta-da-ta-da. Into my computer. Let's see. Okay, maybe I have too much things happening on my computer. Let's do this again. I mean, it does work. Right. Try this backup version here. All right.
Or stairs.
Let's see. Maybe it's Zoom. Let's try and see.
In
Okay, yeah, I think you guys are still hearing me.
a sketch format. Now we need to actually put stairs in. So what we're going to do is we're going to head over to our stair tool. So we're going to go to architecture. Then we're going to head over to stair. Now, this time around, we are going to be using the sketch tool here, create a sketch. And this is how we create custom stairs, right? Whereas before we were creating just a run and a landing, a straight stair. This stair sketch tool really allows us to go in and do custom work. So we're going to click that. And because we have already sketched our stairs already, we just need to use the pick line feature. And before we start picking, we need to take a look at this. There are three parts to a custom stair. There's the boundary, then there is the risers, which are just individual steps, and then there is the stair path, which gives us the direction of the stair, right? Now, each of these needs to be accurately drawn. If it's even disconnected by a half of a millimeter, you will get an error when you try to create your stair. Now, this can be a major issue because if you spend half an hour creating a custom stair, you're going to be unable to save that stairs if the stairs cannot be drawn, if it cannot be generated. During this time, you cannot save your work. So it's a good idea to save before you start to draw your stairs and to ensure that the work is accurate, because while you're in sketch mode, you will be unable to save and you will be unable to exit from sketch mode if you don't fix a stair, if it is not accurate. So you have been warned. So let's start. All right, so make sure that we are on boundary, we're on pick line, and we're just going to be picking the boundaries of the stair. So this side, that side, there, there, and there. We're also going to be choosing the boundary there and this boundary that's here. Now we need to solve this issue here, right? And the way how we do that, we're just going to pull this back here because this little issue would prevent us from drawing the stair. You have to look out for these issues, right? Everything has to meet 100%, right? There is no excuse for inaccurate stairs according to Revit. All right, so now that we have the boundary, next let us put in the risers of the stair. So we're going to hit risers, and we're also going to use the pick line, and we're just going to pick these points here as the risers. Right, so this makes life really easy because we've already went through the trouble to sketch out our stair. All right, there we have it. Now next we need to click to do the stair path, and that's going to be the center of our stairs. So we're going to use pick line again because we already have a center point here and here. All right, good stuff. All right, so now we also need to join these points here. So we're going to use this tool. Make sure that we're on the stair path, and there we go. So now we have a continuous stair path. All right, so with that done, we're going to choose okay, and see, we get this message that says invalid sketch. Now this is pretty normal. The problem is this doesn't always show you where the invalid area is, so we have to now go hunting for this, and we have to solve this because we can't save without it. So there's probably a section here that's not valid.
No, I guarantee you guys, I would love for you to share your horror stories when you are creating these stairs, because I'm sure some of us will have horror stories of like, sir, I spent like half hour creating these stairs and I couldn't generate it because, you know, it tells me the stairs is invalid and I can't find why it's invalid. And if I cancel, I lose half an hour worth of work. Anybody here? Maybe Ansel, I'm picking on you now, but you probably draw a couple stairs that give you trouble. Have you ever done a custom stairs, Ansel?
Yeah, I have. Like you say, it give trouble. You spend bare time doing the stairs and then it cannot form when you're done.
Exactly. So I apologize in advance, guys, because this is a curve custom stairs. In my mind, if you are able to do the stairs successfully, there's no stairs in Revit that you should be able, that should defeat you after this, because it is a curved stairs. It's going up a slope. And it's one of the signature piece of this architecture. I don't know, but usually when you're doing a signature architecture piece, whether it's a museum or something, there's usually something interesting about your structure. It could be a facade, it could be a stairs, it could be the plinth that it's on. It's usually something that is pushing the boundaries of design a little bit. And usually when you're pushing the boundaries of design, that usually takes a little bit more effort to create, especially in Revit. So this will be a great lesson for everyone. So don't get frustrated, guys, when your stairs doesn't create. Just remember, the computer cannot lie. Remember the rule of GIGO. Garbage in, garbage out. All right?
And if we look, there is our problem. We can't have a riser that's not touching the stairs. So we need to actually move this and touch it right at this point. Yeah. So that was what was, we hope, what was causing it. Let's check the others. That seems to be okay. All right, let's try again. Okay, we still have areas that needs fixing, so let's continue to check. Well, all the rises are okay, but looking closely, I realized an error that I made, and that would be that the starting and ending of the steps are actually risers. So I need to delete the start, and I need to replace that with a riser. So I'm going to go to pick line. There we go. And the same thing for here. Because the boundary of the stairs, okay, let's see. Oops. The boundary of the stairs should not be set as a riser. So we need to choose riser and pick line and replace that there. All right.
Guys, this error, it will catch most people. Every time I build a custom stairs, this one catch me, right? So the beginning and the end of the stairs needs to be a riser. It cannot be a boundary. Boundary only represents the edges of the stairs. So remember that one. All right, guys?
So that is how it should look. The boundaries is only for the edges of the stair. So let us choose OK. All right, should connect. Stair path should connect start and ending of riser. So let's see. This is connected. And this is connected. We know from the error it has something to do with the stair path. So that is okay. Oh wow, when you look at this, so this isn't connected here, so that's our problem. So let's do that again. As I said, 100% accurate. It has to be, or else the stairs will not generate. During this time, you cannot save. If you cancel, you will lose all the work. So you just have to push through and figure out why your stairs isn't being drawn. So we're going to go to stair path. Let's make sure that we are hitting it right there. Okay, let's try this again. All right, we now have our stairs. So if we look at that in 3D, that's our stairs, which is apparently going the incorrect way, but no worries. We can just hit the flip tool. And well, that causes an error. So let's see if we can figure out why. Now, if you do get an error where you try to manipulate the stairs in some way, in this case, I'm trying to use the flip tool so that the lower part becomes the upper part, and I'm getting this error. Revit doesn't tell me what exactly is causing it not to flip, but it's saying that, look, if I flip the stairs where the upper area becomes the lower area, I'm going to get a modeling error. Now that could mean that how the stairs was drawn was not accurate enough, but I'm pretty sure that we drew the stairs pretty accurately. We checked for any overlapping lines and everything, and it was fine. Now, the other way to diagnose what's wrong with the stair is it could also be because of the type of stairs. So right now we're building with a monolithic stair, and that means that it's just one cast in place stair. And it might be that that type of stairs, when you flip it, it's causing things to prevent it from being rebuilt. So a good idea would be to try a different type of stairs just to see if the problem is with the type of stairs. So, okay, let's continue with our stairs building. We need to confirm this, because right now we've just confirmed the sketch. The sketch works, but when you flip it, it doesn't work. So there's something in the model that causes it when it's flipped. It causes an error, some kind of weird intersection or something. So let's say okay to confirm our stairs, and you're going to see the stairs with the railings and everything. Now we're going to delete the railings because we don't need the railings. So, right. Now, if we click on the stairs while we are outside the stair tool, we can actually change it to a different type of stairs. So let's try, right now it's monolithic. Let's try precast stairs. And precast is a little different than monolithic. So for example, we could also try we could also try the timber stairs, and now you can see that the stairs looks completely different because it now has stringers at the sides. So these are different types of stairs. So with this new type of stairs, if I go to edit stair and let's try and flip it, and it does work. So what does this tell us? This tells us that our model of the stair is fine, but in the monolithic stair, there is some setting in the monolithic stair that causes it, when you flip it, it causes an error. Now, obviously, this is not the type of stairs what we want. We actually do want a monolithic stair. So, okay, so we are one step closer to solving the problem. So let's choose okay. That's here. Now, let's click on the stair and let's change it to monolithic. We get the error. So there is something in the monolithic stair settings that's causing it to error out. So let's click it. Okay, so let's change it to monolithic. Well, we can't. We need to change a setting in monolithic. So let's undo that to when it was this stair. So this is the monolithic stair that only works one way. But when we flip it, it doesn't work the other way. So let's go into the stair settings, and we could change the we have the width, we have the run, we have the landing type, we have all of these settings here. Oh, this is actually this is precast. We were on monolithic, so let's go to monolithic. Right, so let's check the settings in monolithic. Riser height, riser width. Let's try and change the tread. Let's try and change the thickness. Let's try the thickness. Let's try edit the nosing, because the nosing is usually where a lot of issues lie. So the nosing is this angle that you see right here, and this sometimes can cause issues because the stair is at an angle, but it's also curving, so that might cause issues. So let's actually go and let's make it with no nosing. So let's put the nosing to 0. Hold on, let's see. Run type 25mm nosing. That's the thickness. So let's click on the setting for nosing, and we're going to say let the nosing length be 0. So it's not going to have that tilt. So now notice that the stairs is now straight, which is fine. Okay, moment of truth. Let's try and flip this stairs now. So we're going to go to edit stairs and flip it. And it does work. So therefore, our issue was the nosing. So the nosing was causing an issue with flipping the stair. So if that happens to you, definitely check with the nosing. All right, this is great. And if you look, the stair actually does fall into place for the most part. We do have some areas here that we need to edit. This might be based on your terrain. Now, a good way that we can edit these errors is let's choose OK on the stairs. If you have terrain that is intersecting with the stairs, a neat trick that you can do is we can go to modify sub elements and we can add points. And the trick is that we can add points along where the stairs is. So let's add a point here. Oops. Oh, hold on a second. Let's undo that. Because we need to choose the height of those points. But before we do that, before we add a point, we can actually move these points here. So we can move them around. So if you notice, this point here but it's inside this mass here, so I need to switch to wireframe. Switch to wireframe, there we go. Which is going to make it harder to see. Okay, let's go to top view. Let's see if that helps. Okay, we can better see the points here. Oh, we can tab into it. Let's see, here we go. So what I'm doing is I can drag select it, and oops, some of them I can select, but some of them are actually below the solid. Okay, so for the ones that are below, let's go to wireframe, and let me just move it on the outside. I can use this curve as a reference. And what I'm doing, I'm just moving these points on the outside of the step. All right. All right, now for this point here, what I'm going to do is, let's see, this is 2,500, this is 2,500, so I'm just going to add a point that's 2,500, and I'll add it right here. That's it. Good. So essentially what I'm doing is I'm kind of moving these points to follow the stair in a way, as you can see. So you can kind of make out where the stairs is going. Can you see that? So when you do it that way, let me put back the stairs now. Turn off that, and let's go to 3D view. It's easier for you to shade it. So now all I need to do is to set the height of this point here. I can move it down. I can just drag select and move this down. This one is okay already. This one can go down, so I'll just move that down.
Right, guys, so this is how you modify the terrain to match anything that you put in the terrain, right? So if you're working on a site that has any kind of stairs or roadway or ramp, and the ramp needs to follow the terrain, right? You build your terrain first, you build your ramp, and then you go back into your terrain and add some new points on the edges of that ramp. And then you just move each one of those points up and down in 3D view. And that's how you can get your terrain to neatly follow something that you place in it. All right.
Maybe that's too far. Oops, that's too high. That's good enough. And that's how you can get to carve out the spaces with the stair. By if you move these points along the edge of the stair and then you move them up and down. That is how you can get it to conform with the steps. But it should pretty much follow the steps almost if you use the contours that you got. All right, so that takes care of that. So we now have this custom stair that we built that goes along with the terrain. That's pretty cool. So we've taken care of the hard steps first. Now we need to put some more stairs in this section here. So let's go ahead and do that. Okay, now to add these stairs, it should be pretty straightforward. Let's look at the plan that we have here. Okay, so we have a set of stairs here, and we have a set of stairs here. And the idea is that we have these two stairs, but if we look at our site plan here, let's look at our more refined site plan. Right, so we have a stairs here, and this stairs is coming down and it's just rolling into the hill. So you can see it's almost like the designer wanted the hill to kind of just flow into the stairs here. And then this stairs goes all the way down. The next thing to notice is that there's an entrance below, and we can actually look on our sketches for that. So if you look here, so we have stairs that's going up on this side, but then down here we have a lower entrance. So this is an interesting detail that's right here. Then we also have a retaining wall on this side. That's going to be here. So that is happening. So this area here is happening right here on our model. So we're going to need to cut the terrain out in this section here. And then we're going to need to create the stairs that's going to go up here. Right? These may actually be longer, because when we look on our site plan, let's see, this comes out. This comes out quite a bit more. So I think these walls will be a little longer here. Let's look at our upper floor plan here. Yeah, you can see that we have a 6B grid line. And let's see, where does 6B go? We can look at our here. Okay, yeah, this goes all the way to 6B. So so we can assume that this is our lower floor. So this goes all the way up to here. And this actually stops short. So we're going to estimate that that stops perhaps about here. All right, that's our upper floor. Let's go to our lower floor here. So we're going to say this goes all the way out to here. All right, there we go. Now, one thing that we didn't double check, and this might be different for some of you, is when we click on our stairs here, if we go into our stair setting, you can see, let me come out of the stair setting, hold on. Right, if we click on our stairs here, you can see that this stairs, the base level goes from the lower floor, which is fine, but the top level is to the docking level, which is not fine, because the top level should go to our upper floor, like that. So that way it takes us all the way to this level right here. And then we can actually offset this. So we can offset this. So we can say, we can click on this and we can offset the top level at about 200 millimeters. So that takes us back to right there, right? So that's fine for now. So yeah, so we need ensure that you check that your stairs is going from the right, lower and upper base and top level. That is going to be important for what we intend to do with the stairs here. So let's go to our upper floor and see. So this is where it should start. Now, the thing to note is that the upper floor, the stairs doesn't start from here. It starts from, let's see, pretty much grid line 6A, maybe a little bit after grid line 6A. So this is grid line 6A. So this should actually come back about just when it starts hitting the curve on the, I would say just about here. Choose OK. Don't attach. So for the lower one, I'm going to carry this back like that. And then we do have a wall, this wall here. Let's align that to there. There you go. So that should be about right here. Now, one thing that I'm noticing here is that I'm not seeing this wall in my upper floor plan. I'm seeing the edge of the slab, but I should be seeing the wall do that. Now, if I look here, it's not hidden. That would mean that it has something to do with my view range. But if you notice, if I go to my view range and I try to edit it, it's grayed out. As a matter of fact, you might notice a couple of different options here that's grayed out. Underlay is not grayed out, but view range is. And the reason for that is that because we have a view template, whatever we set in the view template is overriding the view range. So in our view template, we have said, hey, I don't want to control the view range directly. I want to control it through the settings in my view template. And remember, we applied this architectural plan template to many different plans, our lower floor and our upper floor. So what we want to do is we want to release the view range settings. We don't want to control view range using the view template. So let's go into the view template. And where it says view range, we want to say we don't want the view template to control the view range. So we uncheck that and then we choose OK. So now we're able to edit the view range outside of or independent of the view template, which means that we can set a view range for the upper floor different from the lower floor, which is perfectly rational, right? So let's go ahead and do that. So for the upper floor, let's see what we have here. Now you can always use this diagram to understand where these levels are. So for example, right now I am not seeing that wall, and that wall is actually sitting on what is described as the primary range bottom. So the bottom is this level here, but the wall is actually below that, right? If you take a look on our 3D here, so that's our 3D, and to understand this, I'm going to put this over to the side here, right? Then I'm going to go back to this plan and let's go to the upper floor and let's go to view range here. And let's bring up this diagram here. All right, so if you look closely, this wall that you see here, this wall should be shown right here. It makes sense. So this is the edge of my slab and I should be seeing this wall, but I'm not seeing it, which means it has something to do with my view range because it's preventing me from seeing it. And this is something that's very important to understand about Revit, because there are certain things that you're going to want to show on your plans. Let's say you want to show a low wall, or you want to show stairs going below, or you want to show a low window. It all has to do with your view range settings, right? So if we follow the breadcrumb here, we can see that what they describe as the bottom level, which is this, is representing this level here. So that's what they call the bottom. So that means that anything below this, right, is equal to here, this range, which is called our view depth, right? So this wall is below the bottom, right? Because the wall is going down. And if you look at our view depth number 6, that's here, our view depth is set to the upper floor level. That means that the offset is set to 0, which means that you will not see anything below this floor level because the offset is set to 0. So I know this might seem a little confusing, so let's break it down again. So our offset that's here is determined this distance here. So if the offset were 1,000 millimeter, then that would mean we would be able to see 1,000 millimeters below our bottom, which is this here. So right now, this is saying that, okay, right now, you are not going to see anything below our, within our view depth, because the offset is set to 0, which means that this distance here is set to 0, and our wall is located below here. So that's why you're not seeing the wall right here, because it's saying that, look, the lowest that you can possibly see is 0 millimeters below the ground level. So in order to solve this issue, what we would have to do is we would have to increase our offset. We would need to see, we want to see lower than the upper floor level. So let's say we want to see at least 300, no, well, it does, let's say 500 millimeters below. So let's choose apply. Now it's going to say that, well, your view depth is set above the bottom clip plane. So what this is saying is that, hey, it's saying that in this error, that if we put in 500 here, what we're actually doing is saying, hey, I want the view depth, which is how far down we're able to see, I want it to be 500 up, because the 500 is positive. So we would have to put a negative number. That's why it's giving us an error, because you can't have a view depth that's not going down, basically, right? So let us correct that. So let's do negative 500 millimeters and choose apply. Now what you notice now is I am seeing up to 500 millimeters. I'm seeing up to 500 millimeters below my upper floor level, which is why I'm now seeing the wall, which is this wall, because now I'm able to see 500 millimeters below this level. That's right here. So that is how view depth work, and this diagram is extremely useful because there might be reasons why you're not seeing something. Maybe you're cutting a window and you're not seeing it. Maybe there's something showing below and you're not seeing it. Chances are it has to do with your view depth, with your view range, and just understanding what these do will help you to solve that problem. Okay. All right, so now that that is all done, let's choose OK. We're seeing that wall here, which is good. All right, so now we need to put in our stairs. Let's put back this view over here. So we need to add the stairs in, and let's see if we can get an idea of, okay, so we have from 1 going all the way up to, oh, we have 2 stairs. We have one from 1 to 16, and then we have another one that goes from 1 to 15. All right, so basically we have 30 steps to go all the way to the top, right? Which is probably why the design has like 2 options. If you look at the site plan sketch here, so some people can choose the half, to roll up this rolling hill and then have just a few steps, or you can choose to tackle all the steps to carry you from here all the way up, right? Now, I don't know if we necessarily need 30 steps. We're going to let the formula work that out. So let's go ahead and go to our upper floor. And what we're going to do is, we have done this already with our stairs. So we're going to go to the stairs tool. We're going to still use the monolithic stair. And we're going to go between a run and a landing and another run. So let's grab our run tool, and we're going to be using a straight stair. So we're on the straight stair run. And the width of our stair, let's see if we can find that in the drawings. Let's look at our upper floor. No, let's look at our, okay, so it's the same 1600. So our stair width is going to be 16. All right, and we're going to justify it to the left. So it's going to be on this side. So we're gonna go, oh, and let's press escape before we draw it. We want to go from the upper floor. So our base level needs to be the lower floor, and our top level needs to be our upper floor. There we go. All right, now we're kind of doing this backwards because where we start from is going to always be low to high, but we're going to flip it when we're done, so that's fine. All right, so let's start from here. As a matter of fact, I'm going to start from here because I'm going to cut this wall short, so I'm going to start from here. All right, so we're going all the way down here, but we're not going to do it in one go. We're going to go and stop somewhere in the half mark, and I know it's the half mark because you can see how much more steps would carry us to the bottom based on the stair formula. So I'm going to stop somewhere here and click. Then I'm going to go down a little bit further and start again and continue down. So that should give me a flight of steps. So if I look in my 3D view, yes, it's going to be turned the other way, but that's fine. I'll just click it and say edit and flip. There we go. All right, that's looking okay, and we can edit the terrain to match if we need to. We're going to choose OK, and we're going to adjust this wall. We're going to use the align tool. All right, there you go. All right, let's take a look on our sketch, not this one, the more complete one, which is this one here. Okay, yeah, so you can see we have some steps coming up here. Let's see, is there any other view that shows this? Yeah, you can see you have some steps coming up here, and then you have that wall that's here. So, and we have a handrail, but I don't think this is glass. That's here. Anyway, we'll work out the handrails afterwards. For now, let's work on the stairs. So we can delete these handrails for now. And now we need the other stairs. Now the other stairs, we need it to come down just a little bit. I would say what levels do we? Let's carry it down to the level that we had here. So if we look on our section, this level here, which is the landing level. So we're going to carry it from the upper floor to the landing level and see if that works, right? Okay, so let's go back to the upper floor here, and yeah, we're going to draw another stairs. So we're going to go to architecture, stairs. We're going to start here. Let's start it on the right this time. And we want to go from the upper floor, and that's going to be the top level. And the base level is going to go to what we call landing. All right, so we're going to make one run from here. Okay, hold on. We need to change something. Our top level is going to be our upper floor, and our base level is going to be landing. Right, so this should be short. Yeah, there we go. So this should be a fairly short stairs. So let's look at that in 3D. Of course, we're going to flip this. Right, and then we're going to adjust this wall here. Let's choose OK. I'm going to adjust this. Let's delete these railings. All right, that was pretty easy. So we have our two stairs, and it's not bad. It actually takes us into the earth, which is fine that it goes into the earth there. That's fine. All right, now we still need to cut our opening here because there's an opening that's supposed to be here according to our sketch. That's that opening. So this opening here needs to be somewhere here. So we're going to cut like a wall somewhere like that. So we need to remove all of this area here. All right, so the next thing that we need to do is to tackle that section. Now, this is part of a much bigger thing we need to fix, because obviously, as you can see from the model, this terrain goes inside our building. So if I go to wireframe here, you can see that the terrain is actually going inside the building. But in reality, what would happen is that where the terrain hits the wall, the building would be dug out of that space, right? As you can see here. So what we need to do is, not only do we need to cut this entrance in here, but we also need to cut the terrain, that wherever the building cuts the terrain is not going inside of the building model. So to do that, the concept is we need to create a big mass, basically. So we create this mass, which is essentially just a big box like that. And we say, hey, let's subtract this box from this terrain, and you will be left with a big hole in the middle of the terrain, which is where the building would sit. Additionally, we would just extend the box out like this to cut the part that we need for the entrance to the building here. So in a nutshell, like conceptually, this is what we would do to cut this terrain. Now, in actuality, the tool that we would use to do that is called a void form, right? And there's a reason for that. So, for example, I could, let me show you this example. Let's say that I have a floor, and I'm just going to draw a floor on the lower floor. I'm just going to draw it like that. And just for kicks, I'm going to say that this floor is, let me just leave it at 200. So that is our floor here. That's like that. I'm going to just create a new floor. I'm going to call it test. And this floor is going to be like 5,000 millimeters thick, right? Which is ridiculous. But, you know, I'm just using this to get a point across. So I'm going to make this 5,000 millimeters above ground. There we go. All right. So we have this big floor object intersecting with the toposolid. Now I could say to Revit, okay, let's go to modify and let's use a tool that's called a cut tool. And how the cut tool works is that you select your original object and what you want to use to cut it. Bam. Now this object is cut. If I move this, if you can kind of see, the object is being cut into the terrain. And if you can see that right there, right? So if I move this object, it will always cut into the terrain. You see that? Which is great, but the problem is the object is still there. Now I could hide this, hide, and then I would be left with that, which, you know, it does work. But remember, the objective of what we're doing is going to be for drawing. So this is going to cause an issue, because when you go to the upper floor, you'll see this big box here. You'll also have to hide it in this view. When you go to the lower floor, you'll see that big box. You have to hide it. When you go to the elevations, you're going to see this big floor. You're going to have to hide it. So this is not a very efficient way to cut a solid, because, you know, you're going to have to hide this in every view, which is super annoying. So this is why we use what's called a void object. And a void object is essentially an object that is never seen. It's always hidden. Now, this object that we created here is a floor. It's not a void object, it's a floor object. It's meant to be seen as a floor object. A void object, in order to create a void object, we would have to go to a component, and we would go to model in place because we need to model that object. So to continue our little experiment here, I'm going to say model in place. It's going to ask me what category do I want to create for this thing I'm modeling. What are you modeling? Are you modeling a floor? Are you modeling a furniture and electrical equipment? In this case, I'm modeling an object to cut another object, which doesn't really have an architectural definition. So whenever something does not have like an architectural definition, like plumbing, electrical, floor, ceiling, roof, we just put it under generic models because it can be whatever, you know. So we choose generic models, we give it a name. I'm going to call this test cut. So we're doing a little experiment here. Now, once we do that, we will be in a sketch mode where you can't select any object here. You can only create new objects by either extrude, bend, revolve, sweep, and so forth. So all of these objects are created from modeling techniques. Now, usually when you go to modeling place, you're probably building a bench, or you're building a table, or you're building something that you need to model from scratch. In this case, we're going to build what's called a void form. And notice how it looks like an empty cube, because a void form is an object that doesn't exist. It's like you're modeling a ghost. So we're going to choose void form. And how do we want to create this void form? We're just going to create an extrusion. So we're going to do the same thing. We're going to draw the base and choose OK. And we're going to extrude it. The void form is much easier to modify. Notice we don't have to go into floor and set the floor height and whatever. All right, so we created this void form. Now what we do is we say, okay, let's go over to modify, because if we try to click OK, like we have finished modeling the void form, we're going to get an error because it's saying that the void form is not cutting anything. The whole purpose of a void form is that you're using it to cut something, and if you're not going to use it to cut anything, Revit isn't going to allow you to create it in the first place. So we say, okay, then fine. Let's go to cut and let's do the same thing. Select the terrain and select the void form. There we go. And let's choose OK. So now you can see that the terrain is being cut, and it's being cut by this invisible ghost. It's not really a ghost because you know that it is a void form, but you don't have to worry about it hiding it because it will never be seen because it's not an object. Now, if I wanted to select this void form, it becomes very tricky because technically it doesn't really exist, right? Now, I could select the cut area. Notice I can tab into it. So that is the topo solid. This is the cut. And notice it says I have selected a generic model, right? So I can go and edit this generic model. And now that's the void form. So it might be a little tricky to select the void form after you create it, but it's there, but it's invisible because it's meant to be invisible. All right, so let's go ahead and delete that. So that was our little experiment in showing you different ways that you can cut this terrain, and just an introduction to void forms, which is what we're going to use to shape and cut this terrain how we want it to be seen. So now we know that we want to use void forms to get our terrain out of our building. So what we need to do is go to the lower floor, because pretty much we want to draw a box that is the shape of this, and maybe we want to extend it down and like this, because anything inside this shape we want to cut from the terrain. As a matter of fact, I would extend this part out like this because this is supposed to be a retaining wall here for the trucks that come up to the back right there. So this is what ideally we want our void form to look like. We maybe want to extend it down like this some more because we want to get rid of this terrain here at the front too. So that's a concept of what we need to do. Okay, all right, so let's get going. So let's go to component. We're going to go to model in place, and we are going to select generic models because the thing that we're creating is a void form. It doesn't have a category. It's not a floor, it's not a roof. It's just a void form. So we're going to create a generic model, and we're going to call it topo cut, maybe, right? Because it's cutting the topography, topo cut. So we're going to choose OK. And now we're going to create a void form again, and we're going to do a void extrusion. And we can actually just use pick line. We don't have to draw the line manually. So we're going to pick this, pick that. We're going to pick this, pick that, and pick. Where do we want to get rid of terrain? We want to pick this, but then we want to pick that and this. And then the rest we're going to have to draw. So we want this to come all the way out here because we want it to cut this terrain. And we want to cut this back like, we're not quite sure. We're going to estimate this, but maybe like that. Because remember, this is where we have this this wall that's here. It's cut at an angle. So we're going to end up with a wall that's about right here. And that wall is that wall that's right there. Right? So yeah, okay. So so we're gonna trim so that this with that. We don't need this line here. Now we need to carry this forward because we want to cut this terrain here. This terrain that comes around. We want to cut it right here. And then we also want to cut, let's see, we do want to cut into this terrain here because this is a retaining wall. So we probably want it to cut on the outside like that. We probably want it to cut all the way down. And then the rest of it is, this terrain goes underneath the stairs. This part is a little tricky. If you can see here, the terrain really goes right up to the wall below the stairs. Right. And then this wall here is this wall. So it should go right up to this wall. And then this wall. So we're going to trim this like that. Trim this. We need to pick line to pick this wall. And then trim this here. Alright, so this is what we need to cut. So if we look on this in 3D, let's choose OK. We want to cut everything like that. So we're going to go ahead and choose cut, select the terrain, then select here. And there we go. We've cut this like that, which is fine. And we have cut out this little area here. And we have cut inside the building. So we can take a look on our section. We probably need to choose OK. There we go. And we probably need to, let's see. Yeah, we have this on a view template. So on our view template, we're going to disable the view template's control over model display. Right, so let's go shaded. So yeah, you can see that the terrain is not inside our building anymore. It has stopped at this outer wall right here. So that's great. We know that it works. So if we go to our 3D view, let's go to our 3D view here. You can see that, you know, it stopped right here, which is good. All right. Now we're going to add this wall that's here. Let's see if we can figure out what it's like. So let's see what the designer has for us. Okay, so they have this wall here, which they don't have any dimensions for it, but we can use our assumptions to see what it is. So let's go to our lower floor. So we had just estimated this angle, but I think let's get a wall, and let's use a pretty thick one, like 300 masonry. So it starts about right here. And it goes outward. Like about that. It goes a little bit over C1. So that's here, but it doesn't go as far as 6B. So 6B is this one. So, and C1 is this one. So it's doing something like about that, maybe. Yeah, maybe something like that. Yeah, that's probably our wall. So if we look at that in 3D, it's going to look something like that. That wall is actually slanted, I think. If we look at it in elevation, right, so it has a slant to it. So the way how we do that is we will click on this wall here and we will go to edit profile, and that gives us the ability to edit the shape of the wall. So we're going to carry this down like that and carry this down like maybe that, and trim this out. So we now get something like that. Now, of course, we need to cut this earth back, so we need to be able to click on that void form. So let's see if we can do that. Now, if you click on the terrain, that's not what we want. So you want to click right where it cuts. And how you know you've selected it is because this will say you've selected a generic model. And that that generic model we know is the void form. So now we just choose edit in place, and there it is. So we need to go back to our lower floor and edit this line here. We can probably just use pick line to go to there and trim it out to here and trim it to here. Trim there. And choose OK. Okay. All right. There we go. That's looking good. And we know that we will end up with a door in here. We have a weird line here, which is because of how the void form is cut. So let's edit that again. And we're going to push this out to this face. Yeah, there we go. All right, looking good. So now we can see this area here is looking more like this area here. Okay, so now that that's all done, now we have to visit the world of railing and railing modifications, right? Now this is a vast world. There are many different pre-made railings that are out there, but what you will find is if you wanted to get a specific type of railing, there is no escape from the railing properties that's located in Revit, right? So we will investigate how do you download families into Revit, which is fairly straightforward. But right now we're going to investigate, okay, how do we modify the railings that we have already? So if we look on our sketch here, we can see that we do have a railing around this area here, which that would be around this area here. So we have a railing that sits here, and if we can kind of get the style from it, we see that we get a glimpse of it in some of these sections here. So for example, if you look at this one, you can see that it's a kind of a close railing, right? Not much space between the grills. Also, if we look at our sketch of this section area here, we can see we can get an idea of that railing, right? They're definitely close together. So let us go to the upper floor and let's go to our railing tool. Now, if we hit this down arrow here, you'll notice that there are two types of railing tool. We're going to use the sketch method, right? And that's just asking me to save, but I've saved already. So we're going to use the pick line tool, and we are going to place a railing. Let's use the outer part of this wall here. There we go. And we are placing this railing on the upper floor level. Of course, we need to, oops, we're putting another one there. We need to drag this back to about here. And maybe we can put this up to here. All right, and we're going to choose, we can choose the railing type. So this is glass. Let's choose the closest thing that we have, which is going to be the rectangular railing. And we're going to choose OK. Let's look at that in 3D, and voila, we have our railings. Now, of course, the main difference with this railing here and what we have in the sketch is that the railings here are much closer together. So we're going to modify this, and to do that, we are going to go into the edit type for the railing. And if you don't see this preview here, you can actually hit this preview button here, and that will give you a preview of the railing, which is very handy. Now we have a bunch of options here that we can edit, and what I would say is not to get distressed about all the myriad of settings in the railing options, right? Because there's quite a bit. What we want to do in this railing is we just need to put these closer together. That's it. So we're going to duplicate this railing type, and we're going to call this patio railing. And we are going to modify the baluster placement, right? So we're going to choose edit. And this is the awesome thing about these settings. Notice how this railing is highlighted here. So if I click on this, this is clearly telling me that this setting modifies these railings. And you can see that this is the main pattern. And then down here, we have used one baluster per tread, and then here we have the post. So if I click on this, you can see that this is talking about the first post, and this is talking about the last post. So all we have to do is say, okay, our main post, which is going to be this one here, we just need the distance from previous to be smaller, maybe like 100, maybe like 50 millimeters. So we can choose apply. Maybe that's too small. Let's try 100. There you go. And right away, I think with that said, we've got our railing. So that wasn't too hard, because that's the basic type of railing that we have here. Now, these railings are going to be a little bit more tricky. Let's see. Let's look at our sketch here. Okay. Right, we do have a railing that's here. And we possibly have one on this side as well. Could be. What I'm sure we would probably need to have is a railing along the wall. So we're going to look into that. Firstly, let's get the railing on the steps. So we are going to choose the railing tool again, but this time we're going to choose place on stair. And we are going to choose the type of railing. We can work with maybe the pipe this time. and we click the stairs, and voila, we have our railing already done, which is pretty cool. There's our railing. Now it doesn't exactly look like this. For this type of railing, it doesn't have these intermediate pieces, and it has very few vertical pieces, which we already have. So we can go ahead and edit this. So I would click on this railing here. So we have one over here and one here. I'll click on this one, and I'll go to edit type, and I will duplicate it and call it entrance outer rail, maybe. There we go. Railing. All right, so from our sketch, we don't have all of these members here, so right away we just need to get rid of these, which if you go into the railing structure here, you can see that each of these correspond with one of those. So we can just go ahead and delete everything. So apply. So now we have nothing, and choose OK and OK. And yeah, I think this looks more like what we have here. You can see the spaces between them. All right. This one in this sketch, this one doesn't have a railing, but we could put one there if we needed to. If anything, I would argue that the terrain needs to come more up towards this section here. All right, now this side, ideally we would want the railing to be against the wall. So let's see if we can modify the railing settings here. So let's go ahead. All right, so let's go to edit type, and we're gonna duplicate this one again, and we're gonna call this rail. Now let's put the same entrance rail, railing, mounted to wall. All right, so a couple of things here. Well, we don't need these members, and we don't need the balusters. We don't need anything. All we need is one handrail. So we're going to go into structure again, and we're going to delete all of these railings. Choose apply. Then we're going to go into baluster placement, and we're going to say we do not want the pattern baluster. Choose apply. So that's gone. Then we're going to say we do not want the starting post. We do not want the corner post, and we do not want the end post. Choose apply. So now all we're left with is the hand railing, is the top rail, which is fine. Now in our case, we don't even want the top rail. What we want is a handrail, which is different from a top rail, by the way. So, a handrail, you can see here, is in the image, which is different from a top rail. That's here. So what we want to do is we want a handrail. So where it says none, we're going to pick a handrail. Let's see, we are going to pick a handrail. And then we want the handrail to have supports. So metal supports, that's fine. We want the spacing to be, let's put it at 500. All right, let's choose apply. Well, we're not going to see the thing yet. We have to choose OK first. Let's choose apply. All right, we're not seeing it here just yet. The position of the handrail, we're going to say it's on the, let's try the left. Apply. There we go. Now we have a handrail. I think it may be on the right based on our drawing. Now we don't need the top rail anymore, so we're going to uncheck the top rail. Choose apply. So all we're left with is this. And let's go back into railing, because we want to talk about the extension style. So what the extension style is where it ends and it goes back into the wall. That's the extension. This here is linked to that. So what we want to do is say we want the extension style to connect to the wall, and we want the length to be, let's make it 50 maybe. We don't want it to be very long, so let's try 50. And this is going to be at the beginning and the at the beginning bottom. So we're going to apply. Well, we can't see it here. Let's do the same for the top. So we're going to say wall, and we're going to say, let's make that 50. Apply. So there you can see it's going back into the wall. Choose OK. Then we choose OK. And oh, well, it's the other side. So let's go edit this, and let's say, let's put this over here. Right, let's say it's not on the right, it's on the left. Apply. There we go. Let's choose OK. All right, then we have our wall mount railings. Now we do have to also, let's reset our view. We do have to also edit the, well, the top seems to be okay, but the bottom is too long. Now in order to edit this, what we have to do is when we click on it, we have to tab into the top rail. So what do I mean by that? Okay, so let's say that we wanted to edit this rail. We could click on the rail, and that would give us the edit type for the entire railing. Or we could tab and select only the top, or we could tab and select only the bottom of the rail. So in addition to editing the rail, we can also just edit the top of the rail. Now over here, well, all we have is the top of the rail because we turned off everything else. So we actually, instead of clicking on it, we need to tab and click, and that will allow us to edit the, not the rail. Let's tab again. We can now edit the path. So that's going to be something that you have to look out for. You have to tab into the handrail settings, and you will know when you're there because you will see it says edit path. That's here. So we can just click that now, and then we can actually drag this handrail down a little shorter, maybe like that, and choose OK. And there we go. Alrighty, so now we have put in the handrails here, wall mounted handrail. We have customized a handrail for here, and this was the first rail that we put in, which is pretty much what is represented in our sketch already because it's like a glass railing. We can go in and customize this railing, but it's close enough to what's in the sketch in terms of a glass railing. All right, so with that said, we have now completed adding our terrain. We added all our external stairs and railing, custom railings to those stairs, and we were also able to cut the terrain to match, to not go inside of our building, and also learn techniques of how we can cut the terrain to align with our stairs here. All right, so that is where we are. Now our next mission will be now detailing, right? So we'll next now need to add the doors. We need to add those that outer mirror to the wall. We're going to also be adding the windows and all of those other details to our model. So we are now over the half mark. We're maybe about 70% complete. So that's where we are.
Mic check. Hey guys, All right. So that was a little bit of a marathon to get um the stairs in and to get our terrain done. We're almost there. I'm hoping. What's by the way, what's on your? Do you have any deadlines with studio this week? Guys?
Yes, sir. We have a crit on Friday.
You have a crit on Friday. All right, cool. What is it? Interim?
No, it's not.
It's like the what project is this?
What project is this? John? Urban workshop or something like that.
Urban workshop. All right.
Yeah. We have like four crits in total for that one. And Friday is the first one.
Friday is the first one. All right.
Yeah.
So I'm gonna need you guys to navigate this, right? Because okay, our schedule is let's take a look here. No, not this one. Right, here we go. Our schedule is that next week we want to move to add in details. No, hold on. Today is the 9th. Wait. Today is the 9th. Right. All right. So we want to be creating the details. So I have this due on March 8th. That is your next checkpoint. No, hold on. No, March 8th is the one that just gone. So the next one is March 15th, right? So the idea is that the same 1 week to complete everything we did today. That is our schedule. Now, I need you guys to try and keep this schedule. From a realistic standpoint, guys, right? Will you be able to complete what we did today? Stairs. We pretty much did stairs and terrain. Nixa, what is your opinion? Is Nixa here? Okay.
Sorry, asking if you can complete it in the week.
Right, because our schedule is that we do a little in class and you use the rest of the week to complete it. Because next week we're moving on to details. I hear you have a crit on Friday, right? I don't know, you have other stuff as well. I mean, at the end of the day, we still have to get it done, you know. But if we don't complete it, then everything gets pushed down to the end, which is what we're trying to avoid. At the same time, I don't want to necessarily come to class talking about our next thing, like, okay, now we're going to talk about doors and families and stuff like that, but nobody has created the stairs. So I want to get some opinions from each one of you. So what do you think, Nixon?
Oh, it's not Nixon, it's my kid. But I think we should
sorry.
be able to.
All right, that's one opinion. All right, Michaela. Joel, I don't hear your voice from day.
Yes, sir.
Yes, I don't hear your voice from day. So what do you think? What's your opinion?
I think I can finish it. I can.
Cool. I'm not going to bother ask Ansel. Right, Ansel? I think I should set your deadline for tomorrow, right? I'm just troubling you. All right, guys. So the idea is I don't want to move too far ahead from where you guys are at, right? I need you guys to keep the pace so that you guys can finish your individual model. Every time, every class, I keep reiterating that this is a majority of your grade. You're going to need this in order to do the collaboration project. So if you're not finished with your individual project, it's going to hamper you to move forward. So I want to make sure I'm moving along with everybody. If you really look at it, you know, the only things we kind of covered today was the stairs and terrain. It was those two things. So, you know, in my opinion, you guys did terrain last semester when we did 3D modeling. So technically you should know how to do it already. This time we're just adding a little bit more with being able to control the terrain along the stairs. Right? And the only new thing that you guys are doing is building a custom stair, custom curved stair. Which I know is going to annoy everybody, but we all have to go through it. So guys, I'm going to reiterate, you must get those two things done, right? Before we can move forward, okay? So that's where I leave you with today. So the plan of action is next week, we continue moving forward and you guys will finish this, what we did today, the stairs and the terrain before the next class. If you want to get that bonus 2%, finish it before Sunday or finish it by Sunday. That's how you get that bonus 2%. All right. All right. So that is it for class today. I'm going to see you guys later for presentations. Last time we tackled 2. Maybe we can tackle 2 again. We'll see if we can tackle 3. I think it's 3 left. So if it's 3 left, we can try and push to get it done. All right, so later I am going to be seeing here we go. So later we're going to be dealing with links and model line and detail line. Correct, guys?
Yes, sir.
What about reference plane? Is reference plane done? Anybody here from reference plane group? No? Who is that? That is Tatiana. I don't see nobody from reference plane group. Okay. All right, guys, so that is the plan. I will see you later. So take care. All right.
Bye, sir.
All righty.